everyone, welcome to this video about how to simplify an exponent of 1. Before we get started, I want you to take a couple deep breaths because as you breathe deeply, it will allow your body to relax, which will also help your brain absorb the information more. So take a couple deep breaths, give yourself a little bit of love, and let's make this math easy. Okay, so simplifying an exponent of 1 is actually super easy because any number raised to a power of 1 just equals itself. So if you had 6 to the power of 1, that would equal 6. 8 to the power of 1 equals 8. 12 to the power of 1 equals 12. And even if you had really big numbers like 752 or 3026, if you raise them to the power of 1, they're just going to equal 1. And that holds true even if you have a negative number, like -4, or if you have the number 0, or if you have fractions. Basically, any number raised to an exponent of 1 is just going to equal itself. And the reason for that is because of the way that exponents work. So if you have 5 to the 5th power, that means that you're multiplying 5 by itself 5 times. If you have 5 to the 4th power, you're multiplying 5 by itself 4 times. And if you do to the 3rd power, it's 3 times, 2 times for if it's squared. And so it makes sense that if you're doing 5 times itself once, that it just equals 5. Technically, you could say that's not really multiplying because you're not multiplying it by anything. But it's basically just saying that you have 5 once versus like if you have 5 squared, it's 5 times itself twice. So one thing to keep in mind is because any number raised to the first power equals itself, if you ever see a number without an exponent, you can assume that it has an invisible exponent of 1. So for example, if you see the number 2, you could say that that just equals 2 to the first. If you had a number -8, you could assume that that is -8 to the first power because anything raised to the first power equals itself. And that can be really helpful when you're working with variables, particularly, like if you have x, you can see that as being x to the first, or if you have a times b, you could imagine that to be a to the first times b to the first, which can be really helpful when you're doing things like the quotient rule of exponents, for example. Because the quotient rule of exponents says that if you have 2 powers divided by each other with the same base, you can subtract their exponents to simplify it. And if you had something like x to the 8th over x, it would make it a lot easier to do the quotient rule of exponents if you imagine the x to have a power of 1, which you can do because anything raised to the first power just equals itself. And that would make it a lot easier because you could say, okay, well, I could do 8 minus 1, which would give me x to the 7th. You could do something similar with the product rule of exponents, which says that you can add the exponents of 2 powers that are multiplied together. Like this one, you do 2 plus 8 is 10. So if you had something like x times x to the 3rd, you could imagine it to be x to the 1st, which would allow you to do 1 plus 3 equals x to the 4th. So that's just a nice little helpful trick to have up your sleeve to realize that anything that's just by itself that doesn't have any exponent technically does have an exponent of 1 because anything times itself once is just itself. So to summarize, when you're simplifying an exponent of 1, the number that's being raised to the exponent of 1 will just equal itself. So if you wanted to write this in formula form, you could say x raised to the first power equals x. Because any number, regardless of what you plugged in for x, times itself once would just equal itself. And that's how you simplify an exponent of 1. I hope this video was helpful for you. Please comment below to let me know how easy this was for you and then subscribe. For more help with exponents, check out my Exponents playlist here on YouTube or go to mathtutoringonline.com to get additional help by asking a question or booking a one-on-one tutoring session. See you soon!